welcome back, boys and girls. It's your main math man, Ms. Shank, coming to you live from Alameda International High School. And in this video, we're going to be working on some factoring and kind of building some basic ideas with some review vocab first. So it says a factor is going to be a value that divides another given number. So for example, I can list the factors of, let's say, so list factors of, let's say, 21. And so what I'm going to do is this. I'm going to say, okay, what are some numbers that divide 21? Again, we want to get an answer that does not have a remainder, meaning it doesn't have that decimal point. So I can say, obviously, 1 and that number, 21, are going to be divisors of it, but I can say something else. I can say, well, I have 1, I have 3, 7, and 21. And so these are factors of 21 because they divide into 21, meaning 21 divided by 1 is 21, 21 divided by 3 is 7, 21 divided by 7 is 3, 21 divided by 21 is 1. So again, always have that idea of a factor is dividing. Another idea I can say is, let's find some factors of maybe 24. And so I can say, all right, a little bit more factors because it's an even number. So I'm going to have 2, 3, 4, 6, 8, 12, and 24. So again, those are some factors of 24. And now we can say a common factor is going to be a value that divides, still talking about dividing, both of those given numbers. So if I'm talking about a greatest common factor, meaning a GCF of, let's say, 21 and 24, again, I could say, well, look at my list of factors for 21 and my list of factors for 24. I would say, hey, I know that 1 and 3 are in both lists, so I'd say a common factor between those two is 1, and another common factor is going to be 3. However, I'm looking for the greatest common factor, so that has to be one number that is the largest of those factors, which is going to be 3. So I would say 3 is the largest of those common factors. Again, make sure you're saying kind of greatest common factor is that GCF. Okay. So again, now we're going to say, well, what we can do is this. We're going to kind of use this idea for some algebraic expression. So I'm going to be able to factor it algebraically in addition to numerically. So just remember, we're going to be essentially undoing that distributive property. Some other ideas for you. We can say a monomial is going to be one term. A binomial is going to be 2 terms. A trinomial is 3 terms. And a polynomial is going to be multiple terms. And so what we're going to be working with first is going to have a binomial, so we're going to have 2 terms. And again, if you need to, use that vocab sheet like so. Again, we kind of notice in that top left, we have some ideas of what those examples are. So again, we're going to say we have some factors, meaning those terms can be expanded out. And so we can say, hey, I can have, if I have 5b squared, again, those factors are 5 and b squared. But if I expand it out, it'd be 5 times b times b. So again, make sure you're just using that vocab sheet for yourself. So in that first example, I'm going to say this. I'm going to say, all right, I have the expression 2x minus 12. And so essentially what I'm going to do is I'm going to have a greatest common factor of these 2 terms. So I have 2x and I have a negative 12. And so I need to figure out, okay, what is something that I can divide each of those by? Well, I notice I have a variable in my first term, but I don't have a variable in my second term, so that's out of the picture. But what I can do is I can divide each of them by 2. And so that means this. Again, I'm essentially undoing that distributive property. So you're always going to have that set of parentheses, and then I can always check. So let me say that I can check using distributive property. That means this. I can say, all right, I have 2 times everything inside the parentheses, so it's an x and a -6. So then I say, okay, 2 times x is 2x, and 2 times -6 is -12. And so I should end up with what I started with. And so my answer is this simplified expression, 2 times that quantity, x minus 1. So again, when you are factoring, just thinking you're dividing each of the terms inside the parentheses by that common factor. Similar idea, if I have the expression 5x squared plus 15x. So again, 2 terms, going to be a binomial. Make sure you can say, all right, well, how can I write this? I can factor out an x from each of them, and I could say both of these values are, or both of these terms, I should say, are divisible by 5. And so I can say this is the same. This is the same as saying 5x times, and now, okay, if I divided a 5x from both of these terms, what do I have left? I have x plus 3. Again, you can always check it using that distributive property. And so I'm saying I'm multiplying 5x times everything inside that parentheses. So it's just like positive 1x and a positive 3. These two multiplied together is 5x squared, and these two multiplied together is going to be 15x. So again, you should end up with what you started with each time. Now, if you're saying this, and what I'm going to do is actually, I'll do a separate video for the assignment on the back, but I'll actually, I'll do this bottom part first. So now, we worked with doing distributive property. Same kind of idea. We should have sets of parentheses because we're doing the inverse of multiplication. We are dividing, but we have to now say, okay, notice how we have trinomials, meaning we have 3 terms. So since we have 3 terms now, I have to be careful. So I have to say, all right, let's do this. Let's think it's just like undoing that foiling. So again, if you forget, foiling is that first, outer, inner, last. So I should have 2 sets of parentheses where it's multiple terms multiplied together to end up like this expression. So the way it works is like this. So I'll do one and you kind of see how this works. So I'm going to say, okay, hey, I have the expression x squared plus 11x plus 18. And I need to figure out, well, is there a common factor between each of them? There's not. However, what I can say is this. I can kind of use some clues to kind of piece together what I need. So I'm going to say, all right, I have my third term is going to be the product of 2 numbers. Because what I can do is I can always set up my foundation. So I can say, hey, I know that has to be 2 sets of parentheses, and I know to say, hey, I have an x squared, so I need to break it apart. So I have an x and an x, and then I kind of use these clues. So I can say, okay, product, I can say, all right, let me actually say always start. I'm going to always start with this. And so now I'm going to think, okay, what is a pair of numbers, meaning what's 2 numbers multiplied together to give you 18? So let's kind of go through it. So I'm going to say, okay, I have 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18. So those are some examples of, how to get a product of it. So, okay, I kind of narrowed down what these numbers are going to be, but I also need to say, okay, well, since my product is positive, so positive product means that it is going to be same sign, meaning I can have that these 2 symbols are going to be the same, and I can look at this middle term. I can say this is going to be the sum of those 2 numbers. So now what I can say is I have to use my products and I have to use my sums. So I'm going to say I have 1 plus 18, 2 plus 9, and I have 3 plus 6. Because I'm saying the sum of those 2 numbers is 11, the product of those 2 numbers is 18. So if I look at my choices, I could say, hey, I know that it has to be 2 and 9. So that means I can just have a +2 and I can have a +9. Again, you can always double check to make sure you work, again, or make sure your answer is correct. Again, you do that by foiling. So that means this, I have x times x is x squared. I have 2 times x is 2x. And then I have x times 9, which is 9x. And so when I add those middle terms together, I should end up with 11x. So again, make sure you're saying this. If I have, let's say if I have a positive product means signs are the same. If I have a negative product, that means the signs are different. So again, that's kind of the key step first, because if you know that they're the positive product, well, I know that they're going to be the same sign, but they could both be negative. If I know that I have a negative product, I could say, okay, one is going to be positive, one's going to be negative. When you go and look at the sum, make sure you're saying, okay, positive sum means larger value is positive. And the same idea with the bottom part. If you know it's a negative sum, the larger value is negative. So again, make sure you're kind of using those clues. You're saying, okay, look at the product, look at the sum, be able to figure out what your terms are, and have them inside of those parentheses. So now, a little bit less of writing. I'm going to have the same kind of idea for this expression. I have x squared minus 11x plus 30. So we say this is a product. So our product is 30, so I need 2 numbers multiplied together to equal 30, but our sum is negative 11. So again, make sure you use your foundation. Make sure you can say, all right, well, I know that there's the same sign, and I know that they're negative using those product and sum ideas. So what's the numbers multiplied together? Well, I could say, hey, I know that I can have 1 times 30, 2 times 15, 3 times 10, and you guessed it, 6 times 5. So I know it's going to be that last one because 6 plus 5 equals 11. So again, notice how this is equal to 30, which is our product, and this is equal to 11, which is our sum. Since they're the same sign, again, it doesn't matter where I place them. Be mindful of where you do place them, because once we do something more that the order does matter, so just be mindful of that. And then lastly, we have this expression. This is actually a binomial, but you can think of it like this. You can think of it as a difference of the squares. And this is important because these are super simple to do. Because if you think about it, I can rewrite this as a trinomial and say, hey, I have plus 0x in the middle, which is the same thing as what we were given. So I have x squared minus 25, which is the same as x squared plus 0x minus 25. So that means this. I know that this tells me a couple of ideas. Again, product is negative, so that means different signs. So I have my foundation. Product tells me different signs, plus, minus. And my sum, since my sum is 0, that means they have to be the same number. So what's 2 numbers multiplied together that are the same? That gives you 25. You guessed it, it's 5 times 5. And since we have as the middle term 0, that means we have positive 5x and a negative 5x. So those cancel out. So again, our answer is always going to be in that form where you have 2 sets of parentheses, 2 packages multiplied together. And make sure you're going to ask questions at a point in time, rewind, replay, fast forward, use those closed captions, and as always, super slam that subscribe button.